So we saw angle of elevation and depression a little bit during that scavenger hunt. I just kind of like threw you guys into it just to see how it would go. And really, today there's nothing new besides 2 vocab words, and then it's just application of trig. So just a right triangle and a story problem. And we just got to figure out what we're missing. Okay, so just know that's all you're doing today. So let's go over the first word here. Angle of elevation. When you think of elevation, what words or what things come to your mind?
Elevator.
Elevator. Anything else? A mountain. When your doctor tells you to elevate like your ankle or your leg, what does that mean? Lift. So angle of elevation is the angle created from the horizontal of your eyesight. So like if I'm just looking straight ahead and then to where I'm looking to. So if I was trying to find how high up my little projector is, so I'm looking straight, and then the angle my eyes make with a straight horizontal line to the projector would be my angle of elevation. Alright, so right here. So here's where his eyes are, like where they are from the ground up. And he's looking to the top of the light pole, not light pole, what is it called, guys? The lighthouse. This angle here, what is it? Line of sight from that horizontal is the angle of elevation. Now, on the opposite side, the angle of depression, so we have a lifeguard there, right? So when he's looking down on kids swimming, he's looking downward, right? So that's why it's called angle of depression. But if I look here, here's my right triangle. Is this angle in my right triangle? No. But we're smart math kids, right? And if I draw out these lines, what's our special name for these 2 angles here? So close. Not opposite, but what? Alternate interior. Let's circle that. So since we know alternate interior angles are congruent, let's say they're trying to have you find this angle of depression in your right triangle, it'd really be this angle down here. Okay? So just know that angles of depression and angles of elevation are equal. Now we're just going to try problem, okay? Here we go. Oh, I lied. We're not trying a problem yet. Can you guys try to label these angles as either angle of elevation or depression, the numbered ones? So is it an angle of elevation or is it an angle of depression? Is it above the horizontal or below the horizontal? It's kind of all you're really looking at. Okay, for number 1, is it elevation or depression? Depression. What about 2? Elevation. 3? Depression. And 4? Elevation. Everyone get those? Show of hands. Okay, now let's just look at this picture. Give me 1 pair of congruent angles. 1 pair of congruent angles in this picture. 1 and 2, would these guys be congruent angles? Are they alternate interior angles? Then what's another pair? 3 and 4. Okay. Just something to think about. They're equal. Okay, now let's try a problem here. Here we go. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person is in need of help. If the angle of depression to the other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to the person's nearest foot? So I know that's a lot of words, right? But we know we're dealing with the right triangle, so how I would start every problem, draw out your right triangle. Then from here, we're just going to label what we're given. Some of you are kind of artsy-fartsy, you can draw on here. I'm a stick people person, I can't draw. I know my person's down here swimming. I know this is my helicopter. That's as good as it gets. That's my helicopter up in the air. Sorry, guys. It is what it is. Here we go. Now we're going to label. If my helicopter is 18 feet The right side, right, if this is 18 feet above the water, agreed. Perfect. And then we're told if the angle of depression to the other person is 42 degrees. So here's my angle of depression. But is that inside my triangle? No, right? So remember, I have to bring it down here to the alternate interior angle. Perfect. And then we got to figure out what are we being asked to find? What is the horizontal distance from the rescuers to the person to the nearest foot? So horizontal distance, show me with your arms. Is it this way, or like the slant? Right, so we're looking for this. Now from here, we're just going to use our trig. Here's the angle we know. What's 18 with respect to 42? Opposite. And x is adjacent. What trig function uses opposite and adjacent? Ooh, tangent. It's Monday, it's been a while. So tan of 42 equals what?
18.
18 over x. How am I going to get rid of x over there? Multiply by x. Multiply by x. Now what? How am I going to get x alone? Yeah, divide both sides by tan of 42. So what is their horizontal distance? 20. Everyone get that? Rocket. Nice job. And since it's an application, we usually have units, so maybe you should make sure you put that. 20 feet. Okay, so your problems on your homework will look mostly like this, but I have to show you sometimes we're given more complicated ones, and we'll do more of those tomorrow. But let's just do it today together, okay? So we'll see what I'm talking about here. Okay. Belle and Rich are setting up decorations for their school dance. Rich is standing 5 feet directly in front of Belle under a disco ball. If the angle of elevation from Belle to the ball is 40 degrees and Rich to the ball is 50 degrees, how high is the disco ball? So again, what should we start with? A triangle, right? Let's just draw a triangle and see what happens. On this one, conserve your workspace. Give yourself room to write. It's kind of a step-by-step. So there's my disco ball. And then I have, here's Belle. And here's Rich. Oh. Okay, so this one's weird. We're given two different angles. So let's just see what we can figure out. So let's start the first part. Rich is standing 5 feet directly in front of Belle. So this little segment here is 5. Okay. Then we're given the angle of elevation from Belle to the ball is 40. So that's right there. And from Rich is 50. And then we're asked to figure out how high up the disco ball is. So where is that going to go? Where's that variable going to go? The vertical side? Right. So what's the problem with this problem? That's kind of fun to say. What's the problem with this problem? What are we missing? Do we really care about the slant height right now? The slanted side? No. But what am I missing though on that horizontal? We're missing how far this distance is here, right? So what can I call it? Y. Okay. Thanks. So let's start with Rich. Okay. Let's look at Rich. What could be a trig function I can write relating all three of these things? Sine, cosine, or tangent? Tangent, right? Because here's my angle, here's my opposite side, and there's my adjacent. So we're going to write tangent of 50 equals x over y. Now we're going to leave that there for a second, okay? Just leave it. Now if we go to Bell, what's a trig function I can write with Bell? Tangent still, right? So I'm going to have tangent of what's my angle? 40. Okay, what's my opposite side? X over what? Oh, beautiful. See if you guys get it. Perfect. Good from there. But now, the problem is I have two variables, right? So could I solve both of those equations so it's just something like one variable equals everything else? We can. I promise we can. What would be the easiest variable to get by itself? X. Okay? So if we go to the green equation, how am I going to get x alone here? Multiply by y. So y tangent of 50 equals x. Well, that was easy. Perfect. What about this guy? Can I do the same thing? We can multiply by y plus 5. But we're going to keep it in parentheses for now. Tangent 40. Y plus 5 times tangent of 40 equals x. Is that wrong? Because this is a different equation. Okay. Do you guys see how they're both x equals? So now do you guys see how since they're both x equals, I can put what x equals equal to each other? Okay, so let's just try that. So I'm going to have y tangent of 50 equals y plus 5 tangent 40. Okay, before we move on, is anyone confused where I got that from? Perfect. Okay. Can I do anything on this side? Can I simplify this or make it a little easier for us? I heard it. Say it. Say it. What can you do? Distribute. Remember, this is just some decimal, right? This is just like 0.8 or something. I can take this times y and to 5. Okay? It's going to look gross, but I promise it simplifies out. So leave the left side by itself. We didn't do anything to that over there. But now we're going to distribute this tangent of 40 to the y and to the 5. Okay, now remember, when you try to solve for a variable, you want all your variables to go to one side of your equation, all the numbers to the other. So what would make sense for us to move if I want my variables to one side? Yeah, bring y tan 40 to the other side. So just subtract y tan 40. Okay, and remember, these are just really small decimals. They just have weird looking, they just look weird right now. So we have y tangent 50 minus y tangent 40, 5 tangent 40. Don't lose me. We're almost done. We're almost done. Okay, now if we look on that left side of the equation, what can I take out of both of those tangents? Y, right? I can factor out a y. Okay, so let's try that. So I'm going to take out a y from both of these. So if I take out a y from this, I'm just left with tangent 50. And if I take out a y from here, I'm left with tan 40. Okay, last step. Last step. How am I gonna get y alone? Yeah, we're just gonna divide by this whole little parentheses thing. Just divide out. Woo! Okay, now it's calculator work. So those cancel out. So this is what I want you to do. Let's just do it together. And you're when oh wait, let me get this done. So first type in your numerator, 5 tangent 40, enter. I think it's like 4 or something, right? Okay. Now we're gonna divide, so hit divide. Then this whole thing needs to go, you gotta put your own parentheses in. So parentheses, tangent 50, parentheses, minus tangent 40, double parentheses. So remember, your calculators aren't very smart. They only do what you tell it to. So if you don't put the parentheses in the right spot, it's going to do something totally different than what you want. So let me know if you need help. Yeah, perfect. Divide. Now we're going to do the denominator. And 40. Yes, you should get 11.89, 11.9. Okay, you guys help them. I'll be freaking around. Oh, no, I got that.
What do you get ready to do your project?
You gonna hear it? Okay. You gotta put a parentheses after the 50, because otherwise it's something you do after you put a second. Minus. So we gotta see the top. Left side, did you get it? No.
Yeah.
Okay, let's see.
Oh, she got it.
And parentheses, minus, tan, 40.
You were in
Get it? If you're numerator, 5, 10, 40. Divide. Parentheses. Outside of the denominator. So now we're going to end that parentheses there. Minus. All right. Yours good? You guys okay? Okay. That's because your calculator is the worst. Yeah, those are the worst. You get it down? You get it down? Okay. Everyone type in 5, 10, and 40. Enter. Parentheses. Tangent. I'm at the end of parentheses. minus 10.
Oh, wait, I told you.
And then actions.
Yeah, I got that.
It is definitely
Equals n parentheses. Minus 10.
So sorry guys. So sorry.
And why
No, I
is?
got 3.62.
I think I might have fell off. That's not true. I have 3 ones.
It sounds like
I put the room
Okay.
That's so why.
You can even look at my umbrella.
You almost made it.
Yeah.
Oh, they're just.
Okay. So we should have gotten like 11.9, folks. But the only downfall to that, I wasn't looking for Y. What were you looking for? X. This is how far away actually Rich is from here. But we got to plug back into this to find our X. So I know you probably don't have a lot of room. But now that I know that this is 11.9, I can write tangent of 50 equals X over 11.9. And now we just solve like normal.
I wish you could.
How are we going to get rid of 11.9 in the denominator? What do you guys get? 14.2? It's a good day. Great day.